Now let's see the generalization of section formula. Consider any 2 points A, x1, y1, and B, x2, y2, and assume that P, x, y, divides AB internally in the ratio m1 is to m2, that is, PA is divided by PB equals m1 is divided by m2. Draw A, PS, and BT perpendicular to the x-axis. Draw AQ and PC parallel to the x-axis. Then, by a similarity criterion, we have triangle PAQ is similar to triangle BPC. If in two triangles, corresponding angles are equal, then their corresponding sides are in the same ratio, or proportion, and hence the two triangles are similar. Therefore, PA is divided by PB equals, AQ is divided by PC equals, PQ is divided by BC, make it as equation 1. Here we need to find AQ, PQ, PC, BC values. From figure, a QRS is a rectangle. Therefore we have AQ equals RS. From figure we can see that RS equals OS minus OR. As OS equals X and OR equals X1. Therefore, RS equals X minus X1. This implies that AQ equals X minus X1, since AQ equals RS. Similarly, from the figure, PCGS is a rectangle, so we have PC equals ST. From figure we can see that ST equals OT minus OS. As we have OT equals X2, OS equals X. Therefore ST equals X2 minus X. This implies PC equals X2 minus X, since PC equals ST. From figure we can see that PQ equals PS minus QS equals PS minus A, R. Since A, QRS is rectangle, so we have A, R equals QS, which equals Y minus Y1. Also from figure we can see that BC equals BT minus CT equals BT minus PS, since PCGS is rectangle, so we have CT equals PS equals Y2 minus Y. Finally we got the values of AQ, PQ, PC and BC as AQ equals X minus X1, PC equals X2 minus X, PQ equals Y minus Y1, BC equals Y2 minus Y. And given that PA equals M1 and BP equals M2, substitute above all values in equation 1, that is, PA is divided by BP equals AQ is divided by PC equals PQ is divided by BC. We have M1 is divided by M2 equals X minus X1 is divided by X2 minus X equals Y minus Y1 is divided by Y2 minus Y. Consider M1 is divided by M2 equals X minus X1 is divided by X2 minus X. By cross multiplication we get M1 into X2 minus X equals M2 into X minus X1. M1 X2 minus M1 X equals M2 X minus M2 X1. Now taking M1 X to right side, M2 X1 to left side we get M1 X2 plus M2 X1 equals M2 X plus M1 X. Taking X as common on right hand side we have M1 X2 plus M2 X1 equals X into M2 plus M1. X equals M1 X2 plus M2 X1 is divided by M1 plus M2. Now consider M1 is divided by M2 equals Y minus Y1 is divided by Y2 minus Y. By cross multiplication we get M1 Y2 minus Y equals M2 Y minus Y1. M1 Y2 minus M1 Y equals M2 Y minus M2 Y1. Now take M1 Y to right side, M2 Y1 to left side. M1 Y2 plus M2 Y1 equals M2 Y plus M1 Y. Taking Y as common on right hand side, we have M1 Y2 plus M2 Y1 equals Y into M2 plus M1. This implies y equals m1y2 plus m2y1 is divided by m1 plus m2. So, the coordinates of the point P of x, y, which divides the line segment joining the points A, x1, y1, and B, x2, y2, internally, in the ratio m1 is 10 to r. P, x, y, equals m1x2 plus m2x1, is divided by m1 plus m2, m1y2 plus m2y1, is divided by m1 plus m2. If the ratio in which P divides AB is k is to 1, then the coordinates of the point P will be kx2 plus x1 is divided by k plus 1, ky2 plus y1 is divided by k plus 1. Special case, center point of a line. The midpoint of a line segment divides the line segment in the ratio 1:1. Therefore, the coordinates of the midpoint P of the join of the points A, x1, y1, and B, x2, y2, is 1 into x1 plus 1 into x2, is divided by 1 plus 1, 1 into y1 plus 1 into y2, is divided by 1 plus 1. Equals x1 plus x2, is divided by 2, y1 plus y2, is divided by 2. This formula is also called the midpoint formula. Let's learn about points of trisection. If a point P divides AB internally in the ratio 1:2, and point Q divides AB internally in the ratio 2:1, then P and Q are called points of trisection. A point of trisection equally divides line into 3 equal parts.